Assalamu alaikum everyone. We are from Group 4, undergraduate students from the SEEE3533 Communication Principles course. But first, let us introduce our group, which consists of 4 members: Eswaran, Firdas, Shaurul, Adzwan, and Hakimi. We're ready to share our work with you. Here is the list of activities you will go through. Earlier, you have completed Part A of the questionnaire. Questionnaire given in description below. Next, we will show you an educational video to help you understand the topic better. This video will prepare you for the next 2 activities: playing the game and answering the final questionnaire. It covers 8 key topics: the basics of telecommunications, an explanation of modulation, sampling and quantization techniques, the Nyquist theorem, bit depth in digital audio, an introduction to multiplexing, practical applications of multiplexing, and the impacts of technological advancements in telecommunications. Telecommunications refers to the transmission of information over a distance using electronic means, such as cable, radio waves, or other electromagnetic systems. It involves the sending and receiving of data, including voice, video, and text, across various technologies. A basic telecommunication system comprises a transmitter, a transmission medium, and a receiver. What is modulation? Modulation is a key process in telecommunications that involves varying a carrier signal, like a radio wave, to carry information, such as voice, video, or data. The carrier signal, which is a high-frequency wave, is modified in amplitude, frequency, or phase according to the input signal, the information to be sent. This allows the signal to travel long distances efficiently and be transmitted through different mediums like air or cables. There are 3 main types of modulation: amplitude modulation, AM, frequency modulation, FM, and phase modulation, PM. Modulation is essential for radio, television, mobile phones, and internet communications, making it possible to share information across the world. What is sampling? Definition: sampling is the process of measuring the amplitude of a continuous time signal at uniform time intervals. This results in a discrete time signal. Diagram: an analog signal, continuous wave, is processed through a sampler and quantizer, analog to digital converter, to produce a digital signal, discrete wave. Labels indicate the transition from continuous time amplitude to discrete time amplitude. Why is quantization? Definition: quantization is the process of mapping each sampled value to the nearest value within a finite set of discrete levels. Diagram: a continuous signal x of t undergoes sampling to become x and t, then quantization to xq nt, and finally binary coding to xn, represented as a binary sequence. Example: 011001100111. Okay, next we go to the Nyquist theorem. Is a rule in telecommunications that helps us turn analog signals, like sound or voice, into digital signals without losing important information. It says that to accurately capture an analog signal, you need to sample it at least twice as fast as its highest frequency. For example, if the highest frequency in a signal is 1000 Hz cycles per second, you should sample it at least 2000 times per second. This ensures the digital version sounds or looks the same as the original. It's like taking enough snapshots of a moving object to see all its details.
Ever heard of the Nyquist theorem? It's a fundamental concept in digital audio. Let's break it down. The Nyquist theorem states that the maximum frequency you can accurately record is half the sample rate. For example, if you're recording at 44.1 kilohertz, the highest frequency you can capture is 22.05 kilohertz. That's because at 44.1 kilohertz, the system can only handle frequencies up to half that rate, 22 kilohertz, before aliasing occurs. Want to capture higher frequencies? Record at a higher sample rate, like 96 kilohertz, which lets you record up to 48 kilohertz. However, remember that higher sample rates mean larger files and more processing power. Choose your sample rate based on your project needs. The Nyquist theorem helps you understand the trade-offs between audio quality and file size. Subscribe for more audio production tips.
Next, what is bit depth in digital audio? Bit depth in digital audio explained. Bit depth is a fundamental concept in digital audio that determines the dynamic range and precision of audio signals. It defines how accurately an analog sound wave is converted into a digital signal. 1. What is bit depth? Bit depth refers to the number of bits used to represent each audio sample in a digital system. Common bit depths: 16-bit CD quality, 24-bit studio recording, 32-bit float, professional audio processing. Key idea: higher bit depth equals more detail in quiet sounds and less quantization noise. Okay, we go next about introduction to multiplexing. Multiplexing is a clever technique used in telecommunications to combine multiple signals, such as voice, video, or data, into a single signal for transmission over a shared communication line. This process helps save resources by allowing many different types of information to travel together efficiently, like sending several phone calls, internet data, or TV channels through one cable at the same time. By doing this, it reduces the need for multiple separate lines, making communication faster and more cost-effective while ensuring all signals reach their destinations without interference. Last is about impact of technology advancement in telecommunication have revolutionized global connectivity by accelerating communication speeds through innovations like 5G and fiber optics, enhancing efficiency with cloud computing and the Internet of Things, fostering new economic opportunities through video conferencing and e-commerce, improving accessibility for remote and underserved populations via advanced mobile networks and affordable devices, while simultaneously presenting challenges such as heightened data privacy concerns, escalating cybersecurity risks, and the ongoing necessity for infrastructure upgrades to sustain this interconnected digital landscape. Okay, let's go to next session. Play the Ericsson educate.link given in description below. Just follow instruction in video. So the last part of this video is questionnaire given in link below, and the conclusion. The topics covered, from the basics of telecommunications and modulation, to sampling, the Nyquist theorem, bit depth, multiplexing, and the impacts of technological advancements, highlight how these elements work together to create a fast, efficient, and connected communication system that shapes our daily lives and opens new opportunities worldwide. Thanks for watching and cooperate. Have a nice day and assalamu alaikum.